Principles of Bioproduct Separation, Module 12, Crystallization, Segment 4, Recrystallization. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. We have previously discussed about basic concept of crystallization, crystal size distribution, and batch crystallization. In this segment, we will discuss about recrystallization. Although in theory pure crystals are obtained from solution, some impurity almost always remains in the crystalline product. This may occur for several reasons. The impurity may have a similar solubility to that of the desired product, and consequently partially co-crystallize. Sometimes the impurity is incorporated into the product matrix. In other cases, inefficient washing does not remove all the mother liquor and causes contamination. Recrystallization can often reduce impurity concentration. The sequence by which recrystallization is affected can take different forms: simple recrystallization and fractional recrystallization. In the simplest case, the impure crystals are dissolved in a small amount of pure hot solvent and cooled to produce fresh crop of crystals. These new crystals will be purer than the original ones. Such a step may be repeated until crystals of the desired purity are obtained. Steps of simple recrystallization is shown in the figure. In this figure, fresh solvent is designated as S, mother liquors are called as L, and the original crystals are called as AB. The crystal purity increases from X1 to X2 to X3. The purity of the liquors also increases from L1 to L2 to L3. In a sequence of this kind, the yield of product can be low and only a small portion of the desired solute is recovered in the final pure crystals. This is due to the fact that the system operates with only enriching section. The yield of product A can be calculated using equation 33. A better use of the mother liquors can be made with a triangular scheme as shown in the figure. AB represents the original mixture. By convention, A is taken as the less soluble solute and B is assigned to the more soluble solute. The AB mixture is dissolved in a small amount of hot solvent and cooled to produce crystals X1 and mother liquor L1. After the crystals are separated from L1, they are redissolved in a small amount of fresh hot solvent to produce a new crop of crystals X2 and new liquor L2. Stripping of additional A from the mother liquors is accomplished by other applications. The liquor L1 is concentrated further to generate crystals X3 and the mother liquor L3. The crystals X3 are subsequently dissolved in the hot mother liquor L2. Crystallization from this newly formed solution yields another crop of crystals X5 and mother liquor L5. The mother liquor L3 is concentrated to obtain crystals X6 and liquor L6. In each group, purer crystals migrate toward the right of the diagram and impurer liquids toward the left. Consequently, the less soluble product A is concentrated in fractions on the right side of the diagram and the more soluble solute B on the left side. The steps can be quantified using the notation as shown in the right figure, where N is stage and R is the row number. If the initial feed contains a unit quantity of solute and each crystallization operation divides that quantity into a fraction P as crystals and 1 minus P In the liquor, the fractions of the solute for any given step in the triangle can be determined using equation 34. For a better visualization about crystallization, you may want to check these videos in YouTube. Until then, I am Yusuf from Institut Teknologi Bandung.